technologies, they deploy them and then realize we don't know what to do with them. So as organizations look at big data, as they look at new technologies, they have to figure out not only the technology aspect. We can install new servers, we can install fancy new software, we can buy support contracts for it. We also need to make sure our people are able to consume it. And the difference with big data from a lot of other technologies in the past is who actually consumes it. Deploying Hadoop for the sake of the IT department is not going to provide the returns an organization wants. It has to be deployed in a way that the edges of the organization, essentially project managers, program managers, can consume that data in a format they're used to and drive a better decision for the organization. Because if that data, if that technology is not driving some sort of decision, there's frankly no purpose in investing in it. So we spend a lot of time when we talk to customers, we talk to CIOs, trying to figure out where they fall on this maturity curve. And if they fall in the bottom 2 to 3 brackets, modern analytics, modern big data technologies are not for them. They're at a point where they need to look at proven technologies from 5 years ago that are going to help them advance their business, provide them a better return, and not be that step 3 steps up they're not ready to take. So big data simplified. So when we talk about big data, what are we talking about at the end of the day? We mentioned earlier that big data is fundamentally an infrastructure problem. Most organizations define big data as these 3 V's that have become kind of common: volume, variety, velocity. And a company, we say, has a big data problem if they have a relative change in one of these. So big doesn't always mean volumes of data. It could mean that we suddenly want to monitor what people are saying about our brand on Twitter. So we're bringing in unstructured data. Even if it's small amounts of information, it's a big data problem. It's new for the organization. The organization's going to have to bring in new technology skills. The management in the organization is going to have to understand how to change processes and how they make decisions. And the end users in the company are going to have to act differently. So this is going to be a fundamental change for them. There certainly are companies out there that are looking at large volumes of data, petabytes of data, the Facebooks of the world, the automated marketing firms of the world. So that's one aspect of it. But we don't want to get wrapped around it's always a volume problem. Sometimes it's just changing how you do things. So when we look at big data, we like to look at things in 3 different tiers within an organization. We look at analytics, the higher order decision-making tools. These are going to be the visualization tools, other business intelligence tools that are consumed by the end users of the organization. We're going to look at data integration, just moving data around. This goes back to one of my earlier slides where you saw the 5 different silos of data. At some point, we'd like to think that technology will get to the point that we can take all the data we have, put it in some giant box, and then get magical answers. We're not quite there yet, probably a few years from that. So we're at this point where we have to shift data around between environments. HR is going to have to give some data to finance. Finance has to give some data to product management. Product management's got to go get external data from social media companies. So we've got this problem of data integration. Then we've got infrastructure. We've got servers, networks, things that go back in the data center, boxes, stuff we can physically touch. Within an organization, it's 3 fundamentally different profiles and personas that are going to use these types of capabilities. At the bottom, the infrastructure is going to be very much traditional IT folks, system engineers, system administrators. They're going to be worried about the bits and the bytes. How do we get the bits into the data center? How do we move the bits around? How do we protect the bits from disasters? We move up and we start talking about the data aspect. And every organization has somebody that's tasked with data quality, making sure that the data we have is protected, it's of high quality, it's available, it's organized. Typically, it's a DBA. Sometimes they have other titles. And then we look at the analytics layer. We look at kind of who's driving a decision. And this is this magical unicorn role of a data scientist that we keep hearing about. That every organization knows they need 5 data scientists. They just can't find enough to hire because the market's so hot. But this could also be a wide variety of other individuals within an organization. At Dell, we have a tool called SNAP, Social Network Analysis Platform. I think I got the acronym right. It's run by one of our corporate IT teams, and it brings in large amounts of data every day from Facebook, from Twitter, from dozens of individual forums, where people are talking about the Dell brands. It's run by IT people that keep it running on the servers. There's a team of people that do data curation to make sure it's high quality data. But that tool at the end of the day is consumed by people like me in the product management organization, because we want to know, what are people saying about our brands? Are people positive about the Dell brands? Are they negative? And how does that change over time? A good example was Monday. We announced an acquisition on Monday at Dell. A lot of fanfare, everyone was very excited. So we actually watched from a social media perspective, what are people saying about this acquisition? Are the analysts positive? Are they negative? And what are they saying about that? From a product management perspective, that tells us where we need to focus our efforts going forward. Do we have an analyst that thinks it was a bad idea? We need to reach out to them directly because they're an influencer. Do we have customers that are now excited about it? Well, that means we need to focus in on that part of the market. It enables us to make the right decisions very, very quickly. 5 years ago, we never could have told. We would have bought a company 5 years ago, just kind of hoped that the market responded. Nowadays, we have much, much better ways to find clearly what's going on, what's being said. So I mentioned most of this. Analytics is really focused on the access of the data and the presentation of that data. Presentation of the data, and particularly in big data deployments, is absolutely critical. When we deploy new tools and new technologies within our customers' accounts, we never want to deploy something that drastically changes how an individual does their job. If an individual's job is to be down on the factory floor and manage inventory, we don't want a tool that requires them to go to a desktop computer. It doesn't work, they'll never use it, and it'll be a waste of money. On the flip side, if we have individuals that are extremely graphical, visual in how they see relationships and data, we want to make sure we present the results from all this work for them in that visual way. Makes it easy for them to understand, easy to identify relationships. And most importantly, we want it accessible to the end users without having to have too many steps. One of the struggles that we had 10 years ago with traditional business intelligence systems is that a business user had to go back to an IT person and give them a set of requirements. That person would muddle away and build some sort of automated report. It would take them 2 or 3 weeks, and they'd then bring it back to the business owner who gave them the requirements. One of several things happened, none of them good. Either the report was out of date and the business person didn't need it anymore because the business moved faster than the IT team. The individual looked at it and said, no, that's wrong, go do it again. So we had this waste of time. Or the individual kind of looked at it and said, okay, and put it off to the side and we'll get around to it at some point in time. Modern big data tools, there's a wealth of companies on the market, companies like Datamere, Platfora, and Tahoe, that their only goal is to make data accessible to all kinds of people that don't want to understand the plumbing in the back end. So they can go ask questions of, what are people saying about my product? Are people positive? Why are those warranty recalls coming back more often than necessary? Without having to go back to a report generation team. Essentially enabling things to go at the speed of business and when people have questions rather than the speed of a slower IT department or a third party. Data integration, movement and curation is very critical. We've always got to shift data around between the business systems. Curation is also key. In the same way that a large museum will very consciously focus on what they have available to the public, what they have available in the back, and what they're doing to preserve it, that has to be done for data in organizations. We have to understand what's the life cycle of data that makes it valid and valuable before we get rid of it. What do we have to do to make sure the data is accurate so we actually use it effectively and don't make poor decisions off terrible data? There's a good example of this going horribly wrong. There was a big data conference in Austin about 1.5 years ago. One of the new nifty startups was showing their information based on smart meter readings. So they brought in a large amount of data from the power companies, correlated that on people's usage, and then they looked at their accounts and did a lot of interesting things. And somehow they determined, based on their data, that people with Gmail accounts are more efficient with the power in their house, which is just preposterous. Like, how you could look at this and come to that. What it came down to is actually people with Gmail accounts tend to like new shiny technology, like smart meters, so they can better understand what's going on. If you extrapolate the population and look more clearly by zip code, by address, you realize Gmail users aren't any more efficient with power in their house. They just like to know better about what's going on. This is a good example of don't ever do this. You've got to have people in the back that understand what are these correlations in the data be. Cause and effect relationships don't always apply within large data sets. The other place where we're dealing a lot with this is the healthcare market. The healthcare market's trying to change very dramatically as a result of new regulations, new laws in the United States, increasing costs. They're trying to get much better about how they proactively manage their interaction with their patients. And they're a clear place where you can show very small percentages of changes that translate into real dollars. And then data infrastructure, platform and compute, yet again, boxes in the data center. So analytics, we've talked about the visualization piece. The other important piece are the models and the algorithms. And this is becoming a more fast-paced environment. So the models behind analytics are essentially the rules behind how we drive a decision. What are the statistics behind what's a fraudulent transaction in a bank versus a non-fraudulent transaction? The models behind these technologies are what tell us this patient in a hospital, he's probably going to come back, he's not going to take his antibiotics, versus those that will, so they're not going to be a return patient. Those are what drive us to certain outcomes. Well, the patient that's not going to take his antibiotics, he's going to now get a call from the nursing staff every single day to remind him, because that's less expensive for the hospital than him showing up in 2 weeks with an infection that he's not going to go on a different antibiotic. So these models become very, very critical in us understanding what's going on and how we influence it. Then the underlying algorithms. And this is where there's a lot of interest in the community, a lot of discussions. Companies don't quite know how to staff these positions yet. As we start looking at companies that have large amounts of data, they're trying to drive a decision, it's an interesting skill set. You suddenly need someone who's got a deep background in mathematics, someone who's got computer science experience, and they have to have vertical specific knowledge. You've got to have knowledge of that domain so we don't end up with things like your Gmail account makes you save power in your house. And this is an interesting combination to have. So companies are going through a very drastic change in how they train their staff, how they enable them, so that this data gets used properly. Curation and transformation, like I mentioned before, around the data. Essentially, how do we get data from point A to point B? How do we make sure the quality of that data is effective? So, ROI, this is what I mentioned before about people looking at their big data projects, and this is key. Every single customer, when we put a proposal in front of them for a big data project, this is the first thing the executives ask for. They're like, we don't care how much money we're going to write a check for you. I want to know when I'm going to get it back 3.5 times over. So ROI for some things is extremely easy to calculate. My car is a good example. Acura tells me to put premium in. If I don't put premium, I get worse gas mileage. It's very easy to calculate. Big data projects, ROI is much, much harder to calculate because it influences so many different places in the organization. So we've actually built standard models that we use when we're interacting with customers on projects to define what is the ROI expected for a project, and then how do we measure it after the fact. And those are key numbers. We want to make sure that as we execute on projects, we're tracking it every step of the way and adjusting as necessary. So the projects always start out with the same kind of inputs in terms of cost. We've got to buy some servers, we have to buy some cloud services, we've got to buy some software licenses. Big data projects also have a royalties aspect. A lot of companies have to buy data from third parties. Data has become like any other valued traded item. There are companies out there that their only business model is to sell large data sets to other organizations. So as private firms go into this big data space, they want to understand their customers better. A lot of times they're buying data from these third parties, and there's cost associated with that. There's also a skills aspect, and this is where most companies underinvest. Most companies, the reason the return on their projects is so bad is because the skills aspect, they underinvest in. They don't train their people properly, or they don't pay consultants properly. An organization should never do one or the other. They should always do both. You should always use consultants for an outside perspective and training to make sure your team is effective long term. Using consultants for everything is the worst possible thing you could do. The organization loses a lot of the institutional knowledge, can't continue to move on. So we always advise use consultants to get going and then keep it operating in-house. The other aspect is the returns on this. And this is where things get a little squishy. At the end of the day, there are two ways we can increase the bottom line of our company. We can sell more at the same margin, or we can increase our margin. That's it. There's about 1 million inputs to how we do that. Turning the lights down, using a cheaper building, sending our employees remote. There's a ton of things we can do. But at the end of the day, we have to do one of those two things. That being said, there's a lot of ways that we can influence that with data. One of the ways companies do it a lot is just decreasing the product design cycle. Just being able to get faster feedback from your customers and respond to their market needs so you can sell them things quicker. There's upsell opportunities. One of the biggest ways that companies are capitalizing on consumer behavior information is upsell. When you go to Amazon and you click that you're going to buy something, the first thing it does is recommend 5 other things that you're likely to buy based on their algorithms